Hello friends, I am Sanskruti Tamsekar, student of BC Data Science, and in today's video I am going to perform analysis of medical insurance data using R programming. So let's start. We are going to analyze the medical cost using linear regression. So analysis of data needs a data set. To import the data set in our code, we have to create a variable. We have to specify the file type as CSV file. Then header is equals to true indicates the headings in our data set. So I have assigned my object name as dinfo, read.csv to read the file, and this is the path where the data set has been stored. So now we will run this. The file has been read. Now we have to view the contents in our data set. So we will use the function capital BIEW parenthesis and our object name. See, these are the contents of our data set. Now we have to check the summary of the variable charges. So for viewing the summary of the variable, we have used function summary parenthesis our object name $sign and the variable name charges. We will run this. See, here is the summary. This is the first quartile, median, mean, third quartile, maximum. Now this implies that the distribution of insurance charges is right skewed. So we will make sure this visually using a histogram. We can visually confirm the summary by using histogram, and for histogram we will use function hist parenthesis variable object name $sign and the variable name. See, the histogram has been appeared, and as expected the figure shows right skewed distribution. Now moving forward, we have to see the distribution of data and we have to see how the variables are divided. So for the distribution of data we have used function table parenthesis object name $sign and the variable region. See, it has been divided in 4 parts: northeast, northwest, southeast and southwest. Similarly, we have to see the distribution of variable sex. So we have used the function table parenthesis our object name $sign and the variable sex. So we will run this. So the variable is divided into 2 parts, female and male. Similarly, we want to see the division of our variable smoker. We will run this. See, it is divided into 2 parts if the person is a smoker or not, no or yes. Now moving forward, we have to find relationship among variables. So for finding relationship we will use correlation matrix. So for correlation matrix we will use function cor parenthesis object name, C is the column and these are the variables age, BMI, children and charges. We will run this. See, now correlations are at the intersection of each row and column pair. The correlation is listed for the variables. The diagonal is always 1.0 since there is always a perfect correlation. So this was about the correlation matrix. Next, to find the relationship among the variables, here we will use scatter plot matrix. So we will use the function pairs. Here The function pairs is provided in a default R installation by providing scatterplot matrix. So here for scatterplot we will use pair function. Similarly, the object name, column, and the variables. We will run this. See, here is our scatter plot. In the scatter plot matrix, the intersection of each row and column holds the scatter plot of the variable indicated by rows and column pairs. Now, moving forward, we have to add more information to the scatter plot. So to enhance the plot we will use here the package. So we have to install the package PSYCH, as it is not installed in my system, so I will install here. As we know, for the installation of package we have to use function install.packages PSYCH. We are using this package to add more information to our scatter plot. We will run this. The package will install in few minutes. It will take some time for installation. See, the package has been installed. Now we have to load the package. For loading the package, we know we have to use the library function. We will run this. Yes, the package has been loaded. Now, to add more information to the plot, we will use the function pair.panels. We will run this. See now the scatter plot have been replaced with the correlation matrix. The scatter plot below the diagonals are rows presented with additional visual information. Now, moving forward, we have to train a model of the data. To fit the linear regression model to data with R, we will use the function lm. We are using the function lm here to train our data. We will run this. Now here we have used the function lm and the variable charges. We have used here dot, as the dot character can be used to specify all the features. We will run this. It has been loaded. Now finally we will build the model by using the same object. Yes, the model has been built. Here is the call lm, formula is equal to charges, coefficients, intercepts, age, the sex is male, BMI, then the children, smoker, yes, region northwest, here is the region southeast and the region southwest. Now we will see model specification by adding non-linear relationship. As we know, the relationship between independent and dependent variable is assumed to be linear, but this may not be necessarily true every time. For example, the effect of age on medical expenditure may not be constant. So we have to create a new variable to add a non-linear age to the model. So for creating new variable, we have used object, our object $, and h2 as our new variable. We'll run this. Yes, it has been loaded. Then we will convert the numeric variable to the binary indicator to model the relationship by creating a binary obesity indicator. that is 1 if the BMI is at least 30 and 0 if it is less. We will use here if else function. Then we will use if else if 1 if the BMI is at least 30 or else 0 if it is less than 30. We will run this. Yes. Now we will do model specification by adding interaction effects. To interact obesity indicator, that is BMI 30, and the smoking indicator, we will use this formula. Charges BMI is 30 and multiplied by smokers. Now here we will put it all together using the LM function. LM is nothing but a linear model, which is a linear regression. It has been loaded. Now finally we will summarize the result. So here is my final result. This is the coefficients, estimate, standard error. These are the t values, p values, then residual standard errors, degree of freedom, multiple r squares, adjusted r squared, and f statistics. Here my program comes to an end. I hope you like the video and the content was useful. In further videos, I will definitely try to add more content related to the topic. Thank you.